Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of balancing redox reactions, specifically using the ion-electron method. And basically what we got going on here is an example that I will work out later, but for now just use for show. We're looking at a redox reaction between a metal solid and a metal found in the solution. We don't really care about the anion, just the cations here. And if you look on an activity series, you'll see that the copper here will be further down on the list than the silver, so therefore it will be more readily oxidized, meaning it'll give up its electrons and silver would gladly take them. As a result, what will happen eventually over time is that silver will be the solid and copper will be the cation in the solution. Alright? So what are the steps in using this ion-electron method? Well, the first step is to assign oxidation numbers. I'd be willing to bet that most of you haven't looked at your oxidation number rules since we last saw them in Chem 1. So just a quick review on what they are. The reliability trend for these oxidation numbers are as follows. You can most or easily assign fluorine, then the 1A's, the 2A's, the hydrogens, and the oxygens, finally the halogens. Okay, so what are the actual oxidation numbers here? Well, fluorine is a -1, that's a +1 for all the ones in the first column, +2, +1, -2, and -1. Okay, so make sure you know those. Without knowing those, there's no way you can even start these problems. You won't know which ones are going to be oxidized or reduced. Also, if they're in their natural state, the oxidation number is 0. So in other words, all nonmetals exist in a diatomic state, meaning they're bonded to themselves covalently. So if you see that for a halogen or oxygen or hydrogen, its oxidation number would be 0. If you have some solid, Y being the metal, whatever Y is, then what you have is also 0, because metals naturally exist in solid form. And then the ions, finally, they just take the charge as the oxidation number. Alright? So, after you assign the oxidation numbers, you're going to determine which one's oxidation, which one's reduction. And if you remember oxidation, you would have to do what? You would have to you lose electrons. Looks like I got a text message, sorry about that. And R, you gain electrons. So when you lose electrons, you become more positive. And if you gain electrons, you become more negative. Okay, and I'll show you what I mean by that when we do the example video. Now, after you've determined which ones are indeed reduction and which ones are going to be oxidation, then you're going to write two half reactions, and you're going to balance everything but the hydrogen and the oxygen. Okay. In order to balance the oxygen, what we have to do is add waters to whatever side that needs to be added, the opposite side of the oxygen. And then when you do that, if you notice, we just added, when we added the water, some hydrogens, right? So what we have to do is balance the hydrogens. There's no charge there. It's part of the water. Okay, so the way we balance the hydrogens will be to add H pluses. So if I add an H plus, we balance the hydrogens. But now I've added a charge, right? You see the plus sign that I just added in there? So now I have to balance that thing. I'm causing problems for myself, it seems. But eventually it all will work out. You just have to have faith. Well, how do I balance plus charges? I add electrons to both sides. Okay? So the key here, the crucial point that a lot of people forget, is to add them to the right side, the correct side. So oxidation, always when you have an oxidation, you're going to add it to the right side of your chemical half reaction. And if it's reduction, the electrons go on the left side of the half reaction. And you'll see all this in the example video. Then if you have an unequal number of electrons in both equations, then what we're going to do is we're going to multiply both equations, or one equation if necessary, by numerical constants so that we get the same number of electrons. Okay. Then after you get the same number of electrons, you can add the two equations and cancel everything from either side that can be canceled. So if it shows up on either side, just subtract the smaller one from both sides, and then you'll be left with the bigger one on its own side. And then when you're done with that, you're balanced for acidic conditions. Okay? East Alice, somebody's going by and bumping, so I apologize. Got that bass thumping. So here we have, if we want a basic solution for basics, we add hydroxyl ions. If you remember what hydroxyl ions are, they're just OH minuses. And when you have OH added to an H plus, they're both aqueous, you form water. Right? You guys remember that, hopefully. So let's say you have 8 hydrogens on one side left over after you neutralized. You would add 8 hydroxyl ions, and you would get 8 waters. Okay. So if you do something to one side, the universal law, right, keep everything balanced, is to do it to both sides. So add to both sides. And when we add to both sides, we're going to be left with OHs on one side, but then these waters that you created need to be reduced. So whatever side you added the hydroxyls to, the opposite side should have some waters, and you cancel them, and then you are balanced for basic. Okay? So that was a lot of steps. Crucial that you know your oxidation numbers. Then you should understand the concept of reduction and oxidation. Otherwise, you will be in trouble. Break them up into 2 reactions. Add waters, because you introduce some new hydrogens. Add the H pluses, right? You introduce them in the waters. Then you introduce some charges, so add some electrons. Then cancel and add the equation. So multiply to equate the electrons, and then add and cancel. Okay? And then if it's in basic, add hydroxyl ions. Hope everything's clearer now, and I've made things less confusing. Make sure you check out, I'll do a couple example videos for this, so make sure you check them out. And more importantly, you need to practice. Thank you, and have a nice day.